So there used to be, of this Industrial Alliance building, there used to be a graph that went along with it, and I hated the graph, so I just put a picture of the boiler room, which I think is kind of cool.
Yeah, you can just explain instead.
Yeah. Well, we have a graph that talks economics, and it's good enough. Let's see, anything else I did? I hate that graph too. Oh yeah, I did another one. This one. This used to be a page of text.
I appreciate that then.
Should I put verses in between here or something?
Yes.
Or at least a period after verse, one of the two.
That bothers you?
Or verses, I guess.
Is that how you spell it? See, that's the problem. I don't know how to spell it.
Yes, I think that's how you spell it, but I think that looks fine too. Just maybe move it over a little bit.
Move this?
I think that's what's bothering me. Yeah, it's a little bit better.
What do we
I
usually
should-
put in the webinar chat? Those guidelines that are on the front page.
Oh, okay, let me go back there. Oops. Share. It's weird. Why is it there twice?
I think we have a smaller group signed up for today.
This is my last one. I'm so excited.
Julie, and you mean you're not going to do the sales and marketing one with us?
I will join and smile if you want me to.
You can be our panelist.
You could do introductions.
Hey, thank you for joining us.
Whew, I didn't have coffee this morning.
Are you going back to the office next week, Al?
I have not been invited to go back to the office yet.
Oh, we're going
I heard-
back next week.
Into our office? Do you know where
Yep.
you're going?
Yep.
We have a good sneeze shield between us.
Did they tell you if you're moving anywhere?
Well, I'm supposed to be moving downstairs. Well, I shouldn't say supposed to be. Brent had a good plan set up, and then Kim got it, and it became not quite as good a plan.
Put that first screen up again. Your presentation up.
And come on. There we go. Oh yeah. So why is it that at the beginning I always start and I can't get the first slide to go? Bothers me. I just maybe have to be patient. So I have a lot of slides. I have more than 30 slides. I'll have to try to schedule a meeting. What's that?
So you have quite a few pictures in there though, right? Like,
Yeah, I'll be okay.
You're moving pretty quick.
It won't be short. Did anybody from Quebec sign up?
Hold on. We had 4 or 5. Yeah, 4.
What's that?
Nothing. I was looking at which list I need to look at. We're on number 4.
Live on Facebook, live on YouTube. You gotta put it live.
I do not want to put it live. Thanks for asking, though.
There's definitely some from Nova Scotia, but I'm not seeing anything from Quebec. Wow, I can't say that word.
Quebec.
Quebec.
Quebec. Quebec. Okay, how much time we got here?
Couple minutes.
I'm muting myself.
Yep.
Oh wait, quick question. Am I doing the whole spiel again?
Yep.
This thing?
I assume so.
Okay. Okay, we might have some more people join us, but we can get started. First, some quick introductions. I'm Allie Kovash. I'm a marketing specialist here at Steffes.
And I'm Kaylee Lapp. I'm the marketing manager at Steffes.
And I'm Al Tockley. I'm the product manager for our ETS line.
Yeah, so Al's going to go through some commercial applications for our systems today, but first, just so you know, you'll be on mute throughout the presentation. And you can ask any questions you like, just put them in the Q&A section and we'll keep an eye on those and ask them to Al after we're done. Al, want to take it away?
All right, here we go. So today we're talking about commercial applications. Specifically, we're going to talk about room heaters and our ThermElect product line. There are applications from time to time where Comfort Plus can also be applied in the commercial applications, but today we'll just concentrate on these two. So, you know, as we've been talking over the last 2 months in our webinar series, the ETS technology is really the same, whether we're looking at room heaters or, you know, up to an 80 kW, half megawatt hour a machine like our 9180 ThermElect. But we have all kinds of flexibility and can do all kinds of different control strategies that meet both the building owner need and also the utility need. So we'll start with our room heaters. We have 5 sizes of room heaters, you know, all the way from 13.5 kWh up to 40.5 kWh. Those are, you know, different series 2102, 2103, 2104, and so on. The beauty of room heaters is there's no ductwork, no plumbing, anything. And I always get to show this slide, so I'm always happy about that. So just some examples of some of the applications we had with our room heaters. You know, large daycares. We've also done, I don't have a slide of this, but elderly housing as well. We get asked a lot about, you know, can you put room heaters into these kind of applications? The you know, skins get hot. Are they dangerous? And the answer is, we've never had any trouble with it. We have done several different daycares, lots of homes that have young children and older people living there. So they do work out really well in those kinds of applications as well. Here's an example of an art gallery in Du Bois, Wyoming, where they built a little shelf around the ETS heater. Courthouses, we've done a ton of courthouses over the years. The one on the right is actually Lemoore County Courthouse in Lemoore, North Dakota. It was the first one we did. I think the year was 1996, so it's been a while ago. And those heaters are still operating real well in that application. And what these courthouses, especially in North Dakota, they were all built about the same time, about 100 years ago. They had coal boilers as their heating source. And while the thought was always that coal was really cheap, the overall systems were incredibly inefficient. And you always had the problem that the lower levels were way too hot and the upper levels were too cold. And they really didn't have much control anymore. And so when we looked at the ETS project in this building, it was originally thought that ETS room heaters would be the least expensive installation because of the fact that you know, all the piping and boiler and everything else had to be replaced, but that operation would be a little bit more than that coal boiler. But what they found is that operation was actually much less because they no longer had to have somebody on call 24/7 to keep that coal boiler running. They also had much more control from room to room, so they would keep the courtroom, for instance, which was upstairs, warm during the times when they were going to have court, which was usually once a week. and let it be cooler during other times. And they just found it to be much more comfortable and much more efficient than the systems they had in the past. Schools, same kind of thing. They typically are older buildings, or in a lot of cases are older buildings, and they might have radiators that they're heating with now, or even if it's forced air systems, room heaters that are a nice choice because they're able to again put that heat where you need it in the building. Churches are another great example that we've done over the years. It's one of the things that's fun about churches is you'll see in a lot of them they have little cutouts where the radiators sit in the sanctuary areas, and in those places we've taken out the radiators and put room heaters in their places, and it's just done a really nice job. Apartments certainly have the ability to do apartment buildings as well. Hotel rooms. So that's our room heaters. We do have some different control strategies that we are able to do. So if there are the desire to do controls, we can either use our new transceiver and our Steffes Connect app to control the different heating systems, or we could do a gets kind of system and have control and actually bid those things into the market. So lots of different ways that we can control room heaters to provide value in a commercial institutional kind of application. Okay, so now we're going to talk about our ThermElect product. And our ThermElect can be up to a half a megawatt hour of energy storage. I see our numbers on the bottom are a little bit off there, but 80 kW. It's a hot water output, which gives us lots of flexibility, and we'll talk about different applications there. In terms of how the system works, in charging, our technology really all the same. We're going to store that electricity, that cheap electricity, as heat, and we're going to use off-peak times. But we also in commercial buildings, a lot of times you have relatively low-cost energy and then have a demand charge on top of it. So if we can utilize that low-cost energy and not add to the demand, we can see some significant savings. So I just want to talk about how the heat is delivered. If you remember us talking about our 5100 series, it really works very similarly. Over on the left-hand side, we have our variable speed core blower, and when there's a call for heat, we circulate water through the heat exchanger in the base, and we monitor the discharge water temperature, and we will vary the speed of that blower to maintain whatever our temperature set point is. So for instance, if we were doing all in-floor heat, we might want to maintain that at 100 degrees, but more typically, especially in commercial applications, we're doing 180 or 185 degrees, again, depending on the application. Charging inputs, we have two different sizes. We have the 53 kW and the 80 kW. Here's an example of a school in Quebec. They put in just one 9180, and they were able to get a payback in 1.4 years. And how they were able to do that is kind of signified by this graph. The blue line is their energy usage before they put in ThermElect, and the red line is the energy usage after they put in ThermElect. And maybe I shouldn't say energy usage, I should say power. And they were able to cut, with one 9180 and some controls in the building, they were able to cut 110 kW off of their demand. So multiplying that out by the year, they were able to save, get payback in 1.4 years. So that's the kind of thing that you're looking to do. What can we do to put the heating system in and not add to the demand. Here's another example of a large building that we did in Quebec, Industrial Alliance building. And you can see this is a mechanical room. I just wanted to show that, you know, there's several of the ThermElects in there, so we can just gang them however many we need. And then they also have a gas boiler for backup. And this gas boiler looks like it was built in about 1930. So that's a real typical application where we'll have some fossil fuel as a backup or as part of the system, and also have ThermElect there. Very common where we'll have the ThermElect trying to do most of the heating, and then just have the boiler there for backup on the coldest days. And this one just shows that we're able to gang those systems. This is, again, real common where there's a main primary loop in the heating system, and controls are being set up to bring the heat from multiple heaters. One of the questions we get asked a lot about when we're putting multiple 9100s into an application is the controls guys are used to, if they have multiple gas boilers, for instance, they will alternate which ones run so that they get kind of even runtime on each one of the boilers. What we recommend is to use each one of the units the same. So we want to be putting in the same amount of energy and extracting the same amount of energy from each one of our 9100s the best we can. What that allows us to do is keep the peak temperature as low as possible. And just kind of a general rule of thumb is for every 100 degrees that you're able to keep an ETS heater cooler, you double the life of the heating elements. So what we're trying to do is not run at full temperature all the time if we don't have to. Here's just another example, more units, you put them in parallel with each other. Here's another example of a domestic water heating system. This is can do a nice job of providing hot water, and typically you have to have a heat exchanger in between the heating source and the domestic water. Even though in our particular system, since we just have a copper heat exchanger, we could run domestic water through our system. It's just not common to do that in the industry, and by not doing that, you keep the contaminants that happen to be in normal domestic water systems out of our system. I get asked a lot about, well, why would you use a ThermElect instead of just having a big water tank there? And the reason is we have a volumetric efficiency of about 10-to-1 compared to water. Even though the specific heat of water is much higher than what our bricks are, our bricks have two advantages. One is they're super dense, i.e. you put them in water, they sink, meaning they're more dense than the water. And they also have we can get them really hot, right? So we're gonna get the unit up to 14 or 1500 degrees Fahrenheit, and so we can provide that hot water to the system. To do that with a storage tank, you're going to need a 2,500 gallon tank. You're going to have be able to support 18,500 pounds, and the footprint of it is much bigger. So that is something that's a little bit different. I will give a little bit of a teaser though, in that at Steffes we're doing some work with some heat pumps for this specific application, and we'll probably be using some water tanks in those. So if you have some commercial domestic water applications, we encourage you to give us give us a call. We'd love to talk to you about them and talk about some of the work that we're doing with some of the new fun refrigerants that are out there. So how do we size this system? So in a typical residential scenario, we are doing all of the heating in the home, so it's pretty simple, and there's usually very defined on-peak and off-peak periods. And so the Steffes heater, we come up with our maximum maintainable heat loss charts, and we apply them to our heaters. Now, we can do that with the ThermElect, and if the ThermElect is on a time of use or just a very set time schedule, and we're doing 100% of the heating, doing that maximum maintainable can make a lot of sense. However, if we're doing peak shaving, for instance, and in a building, and we're trying to keep our demand as low as possible, we might not have to completely turn off the ThermElect at any given time. And so it becomes a little bit more of an engineering exercise, and the engineers typically look at what the heat need is, because it might change during the day depending on how much fresh air they're bringing in, how many students are in a school, for instance, lots of things like that. So we provide this chart that shows the amount of time that there is at a given output. So just what this would mean is, if you had a 40 kW output, we could maintain 40 kW for 8 hours. And so if that was your peak time that you were trying to achieve, this particular ThermElect would do the job for you. So just again, there's lots of flexibility, which can be a little bit more challenging when we're looking at doing heat loads. But again, if you have questions, give us a call. The hydronic system, I guess the main thing there I want to talk about is our delivery temperature. We can do as hot as 185 degrees. So if you have old radiators in a building, we can do that. And the maximum output that we can do is about 300,000 BTUs per hour, which works out to about 80 kW as our maximum output. We just made a design change to our ThermElects, and we have SCR Control built into our ThermElects today. What that does is that allows us to infinitely vary the amount of charge going into the unit at any given time. So if we're using a building automation control system, and we're looking at what the building load is, we can throttle the ETS heater charging up and down to fill in the valley and to give us that really flat load curve and provide that lowest cost heating. It also would have some advantages in terms of longevity of elements. The way we're controlling it now, we're able to, at the top end, keep our elements cooler, which of course gives us longer life. I mentioned building automation control. BACnet interface is available that allows you to control the units from remote locations. So how do you determine the feasibility of the project? Well, we need to decide what it is we're trying to do. Are we trying to avoid demand potential? Are we trying to just take advantage of off-peak rates? So by looking at a daily usage profile, typically on the coldest day, we can see how much energy is available and how we can fill in the valleys to provide that low-cost heating ability. And this allows us to increase load factors on the buildings, fill in the valleys, and decrease the average cost per kWh for heating those buildings. And with that, I am done.
Doesn't look like we have any questions today. So if you guys think of any afterwards, feel free to reach out to us and we can help you out. But yeah, none submitted right now. You can go to the next slide. I'll let you know if somebody else submits one.
Hold on, we just got one.
Pardon?
How much support can Steffes provide to our sales folks in terms of sizing and applications?
I'm assuming Julie Thorpe asked that question. Well, you know, so at least in the days of COVID, we're having a hard time traveling into different markets, but certainly we'd be willing to help look at sizing. We'd be willing to look at load factors and those types of things. You know, we do have the ability to do some of that. You know, it's not, we don't have people that are set up specifically to do those kinds of things today, but we do have lots of knowledge within our group to help out.
Okay. Yeah, so our next webinar is going to be on August 6th, and that one is going to be on marketing and sales training. So Kaylee and I are going to go over kind of some of the resources that we have available and talk about some of the messaging and different ways you can advertise, things like that. And then on August 20th, Julie is going to talk about the tech resource library and about, you know, those kind of resources that are available there. So I'll be sending out the next newsletter here, first part of August, and the signups for the 20th will be there. So look for that.
Thank you.
Thank you everyone for coming today.